Let's see how we can solve this rational equation by following these 3 steps. The first thing we need to do in order to find the LCD, or the lowest common denominator, is to make sure all of our denominators are factored. The only one that's not currently in factored form is this middle one, which is a difference of squares. We can factor this as x plus 5 times x minus 5. Now the process of finding the LCD is looking at all the factors that show up in denominators and making sure that they're all included once. If there were a squared factor in a denominator, we would need to include the squared version of it. But if a factor like this x minus 5, for example, appears twice in different denominators, we still only include it once in the LCD. So I need to make sure that I have x minus 5, x plus 5, and x. If I have these 3 factors, then every factor that shows up in a denominator is covered by the LCD. So my first step is to multiply both sides of the equation by this LCD. So I'll put the x first because that's a little bit more standard order to write this in. X plus 5, x minus 5, and I'm going to multiply this by the right-hand side of the equation. Then I'm going to do the same thing on the right-hand side of the equation. I'm going to multiply 3 over x by this whole LCD. All right, now on the left-hand side of the equation, it's a little bit more complicated because we have 2 separate rational terms. Note that these are separated by subtraction, but each rational term needs to get multiplied by the whole LCD. So I'm going to bring this whole LCD in and distribute it into the left-hand side of the equation. On the right-hand side, I have only one rational term, which makes it a little bit simpler. I'm free to go ahead and cancel common factors at this stage, and I can do so with a pen. I can actually slash through that factor. I don't want to do that on the left because the cancellation will be different for each one of these terms. I'm going to write this out the long way by writing the LCD with each of those rational terms this first time through, just so that we can see what happens. So, writing this out the long way, we can see that we have the whole LCD multiplied by the first rational term, and then because these are separated by subtraction, I put a subtraction here, the whole LCD again multiplied by the second rational term. And in fact, I'm going to write the denominator in its factored form here because it's a little bit easier to see the cancellation this way. Okay, so in our first product, the factor of x minus 5 in the denominator cancels with the x minus 5 from the LCD. In our second product, the x plus 5 and the x minus 5 from the denominator both cancel with the x plus 5 and the x minus 5 in the LCD. Over here on the right, I can see that my factors of x canceled, leaving me with just a 3 from the original equation and just x plus 5 times x minus 5 from the LCD. So putting all of this together now, we can see that what I have left in the first term is 2x times x plus 5. In the second term, I have just minus 20x. And on the right-hand side, I'll go ahead and multiply out this product of conjugates, x plus 5 times x minus 5, following the difference of squares pattern, is x squared minus 25, just a 2-term result. So that in the next step, I'm ready to distribute into the 2 sets of parentheses that remain. This becomes 2x squared plus 10x minus 20x equals 3x squared minus 75. Now the only like terms on the same side of the equation that I have are these two, so I'll go ahead and combine those to get ready to start moving terms in the next step. Okay. So at this point I can see that I probably have a quadratic equation and I'm ready to get the terms all on one side. I'm going to choose to move everything to the right instead of the left because I like to choose the direction that gives me a positive leading coefficient. And just looking at these x squared terms, I can see that moving them to the right is going to give me x squared instead of minus x squared. So that's the direction I am choosing to move everything. But again, you can move things to the right or to the left. It doesn't make a difference. So these are gone, these are gone. All I have on the left is 0. And over here I have x squared. I'm going to swap the order of these two terms here, which are not like terms, to put them also in order of descending powers. So that will be plus 10x minus 75. Now a quick factoring here. These factors would have to both start with x in order to give me a first term of x squared. They must have opposite signs because my last term is negative. And I'm going to say 15 and 5 look like good choices to get me the correct middle term. Just as a quick check, the outer term would be negative 5x. The inner term would be plus 15x, giving me the correct middle term of positive 10x. And therefore this gives me two solutions, setting each of these factors equal to 0 according to the zero product property. Okay, we're not quite done with this problem. Let's look back at our list of steps at the very beginning, which says we want to multiply both sides of the equation by the LCD to clear the denominators. We did that. We solved the resulting equation, which in this case turned out to be quadratic. We still have to do this last step, which is to make sure that the solution is in the domain. Now the domain in this case is all values that don't give me division by 0 errors. So one way I could find the domain is to look at the denominators of the original equation, all three denominators. But note that all of the factors that show up in denominators are also in my LCD. So a quick way to find the domain is to just look straight at our LCD, and any factor or any value that would make one of the factors in the LCD equal to 0 would also make one of my denominators equal to 0. So that means that we cannot have x be 5, negative 5, or 0. Those are the three values that would give me a division by 0 error in one of the expressions in the original equation. So now let's look back at our solutions and see if any of them are not in the domain. Looks like negative 15 is fine. That wasn't one of the listed numbers, but 5 was one of the listed numbers, so we have to throw it out. So any possibility here, you could have two solutions, both of them are in the domain. You could have one solution that's not in the domain. It's possible you could have two solutions, neither of which is in the domain. We throw out anything that's not in the domain, and if there's anything remaining, that is our solution. If there's nothing remaining, that's the situation where we would then say no solution. But here we're going to say that our solution set is just the value negative 15. So this example was fairly long, but it encompasses a lot of what we see showing up in rational equations. Some of them are simpler, but we shouldn't really see any steps that didn't show up here.